Hello everyone. For this subtopic on kinetic model, we are going to use the kinetic model of a gas to explain how it gives rise to the pressure of the gas. Now we learned in the previous chapter that pressure equals force over area. So the basics is still the same, force over area. But now we are going to take force over area, we're going to break it down into smaller components. We're going to take force and we're going to break it down into the molecular behavior, and we're going to take area and we're going to break it down to how it is seen from the molecular level. Now take some time to study this animation. If you need to, you can refer to the link below to go to the animation and study it yourself. So from this animation, what can you conclude about how the molecules of the gas give rise to the pressure of a gas? If you were to look at the whole chamber itself, it's going to be maybe a bit difficult to see, but what I'm going to help you with is isolate one small section of a chamber. Now, based on this small section of the chamber, observe carefully. What do you think gives rise to the pressure at the molecular level? First of all, you can see that the number of collisions between the molecules and the walls of the chamber gives rise to the pressure. Right, as I already said, force over area. So the collision gives rise to the force. The speed of the molecule also plays a part. So the average speed of the molecules at which it collides with the wall of the chamber also plays a part in the force factor. And the other thing also is the time taken between collisions. This also plays a part in the force factor. Right, try and think of it. If you were to keep hitting the wall many times in 1 second, definitely you're going to feel very painful, right? And also the area on which collision takes place. You must not forget the area because it plays a very important role in understanding pressure. Now once we isolate these four things, we can even break it down even further. The number of collisions of the air molecules on the wall per unit area. So this gives rise to the gas pressure, and the number of collisions of the air molecules on the wall in 1 unit time. Usually it's 1 second, but I'm going to say 1 unit time also gives rise to the pressure. And the speed at which the molecules strike the wall also gives rise to the pressure. And therefore, to describe the pressure of a gas at a molecular level, we say that the number of collisions of the air molecules on the wall per unit area per unit time gives rise to the pressure of a gas. Per unit time, it also can be interpreted as frequency. We also can say the frequency of collisions of the air molecules on the wall in 1 unit area constitutes the pressure of a gas. Okay, to further add on, whenever we discuss about pressure of a gas using kinetic model, we must always remember to talk about these three main things. Number one, the number of collisions of the air molecules on the wall in 1 unit area. Number two, the number of collisions of the air molecules on the wall in 1 unit time. And number three, the speed at which the molecules strike the wall. Always revolve around these three main points to help you describe comprehensively how the pressure of a gas behaves when volume and temperature changes.